Hey guys, have your notes here for section 5, 1 day 3. Again, problems get a little bit harder. I'm going to show you some new techniques to try when you encounter your homework problems tonight. I have my list of substitutions that I could make close by. We're going to need them today. So, first example. Now, something I haven't mentioned is there is often more than one way to do these problems. So, my way isn't the only way, but whichever way you go, you have to show every single step because you're doing a proof. So, I think I am going to start by changing everything to sines and cosines. I'm just not that comfortable with cotangent. I'm not that comfortable with cosecant. What that's going to end up doing, though, and you're not going to like this, but it's going to end up creating a fraction within a fraction. Actually, it's going to create two fractions within a fraction. But I think that's the best way to get to where we need to go. So, cotangent, here's what I'm going to do. Cotangent, I'm changing this to sines and cosines. So I'm going to change my cotangent to cosine over sine. Okay, and I'll color code it for you. That's the first substitution that I made. I encourage you, whenever you have fractions within a fraction, make your main fraction bar longer and darker. Make your main fraction bar longer and darker. So cosecant, I'm going to make this substitution down here. Cosecant is 1 over sine. 1 over sine. That was the next substitution that I made. Equals, and I'll leave this one as a cosine. Okay. Hopefully you're comfortable with those two substitutions. Now, here's a common technique that you'll want to use. When you have a fraction divided by a fraction, I want you to do same, change to multiplication, flip. Same, change, flip. Here I go. Same. Change. Flip. Same, change, flip. Just as a reminder what we did there. Now, you ready for this? When you're multiplying fractions, sure, you can multiply across the top and multiply across the bottom, or just go ahead and reduce before you multiply. Go ahead and cancel before you multiply. This sign cancels with this sign, and oh my goodness, I get cosine on the left. I have cosine on the right. Well, that was easy. The key to that problem, same, change, flip. Next one. Well, one of them is a fraction. Okay, so remember how I said sometimes you have a couple of options. First thing, one thing you can always do is turn everything into sines and cosines. If you want to do that, if you want to try it, go ahead. It'll work. It will work. I think I'm going to get a common denominator here. Okay? I'll get a common denominator so that they're both fractions and I can combine them. So I need to multiply this by tangent over tangent. Tangent, tangent. common denominator, combine them. Ooh, I think that's a thing. Is that a thing? I think it might be. Let's look for it. Go to that paper that has a big list of tables. Do you see tangent squared minus secant squared? You see it? Tangent squared minus secant squared. Tangent, oh, so close. I see secant squared minus tangent squared. Dang. What's the difference? Well, here, our tangent is positive, our secant is negative. Here, our secant is positive, our tangent is negative. You know how they're related? By a negative 1. By a negative 1. In fact, take this quantity. I can't sub anything yet, so I'm not going to highlight it. Let me take away my highlighting. I'm going to factor out a negative 1 from my top quantity. And here's what I get. Ready? Factor out a negative 1. Doesn't this secant now become squared? Doesn't this secant squared now become a positive secant squared? Factor out a negative 1. Doesn't this positive tangent squared now become a negative tangent squared? Mm-hmm. Now, is that a thing? Do you see it? Is it on your table? It is. It's right there. So this big quantity right here just becomes a 1. And that becomes a 1. So we're pretty much done. And I came over here just to make them match, and I left my negative and put a 1 over tangent. I turned my cotangent into 1 over tangent. Yay. Okay, last one. This one gets fun. This one, you know how, okay, over here I decided to get started by turning everything into sines and cosines, but over here I didn't. Oh, because over here there was something else to do. Like I saw that I had a fraction and I could go ahead and subtract my fractions. There was another option for me to do, so I went ahead and took the other option. Didn't have to, but I did. How about here? Do you want to turn everything into sines and cosines? Or is there something else that you see you want to do? Like, is it saying, hey, add these fractions together? Or no. I don't see any other place to start besides changing them all to sines and cosines. So, I think I will. 1 over. Whew, here we go. This one is going to turn into 1 over sine. This one is going to turn into cosine over sine. Remember how I said if you have fractions within a fraction, make your main fraction bar a little bit longer and darker. Equals cosecant. I am going to turn cosecant again into 1 over sine. And I'll turn this cotangent into cosine over sine. Okay, I see a lot of similarities, but they are not equal at all. Like I can't verify that they're equal just yet. We have some work to do. So the last time you had fractions within a fraction, I told you to do same, change, flip. You can't do this right here, not yet, because same, change, flip is not a thing. You have to have a single term denominator. You can't have two fractions in your denominator for same, change, flip. So, not a big deal. There are two fractions. They already have a common denominator. Combine them. So the 1 stays on top, big fraction bar, 1 minus cosine over sine. Right? I just combined my two common denominator fractions into one. Oh golly, now I have to go and write all this. Actually, hold up. Let's go ahead and combine those two. Less writing. Let's do that. Let's do 1 plus cosine over sine. There we go. All right. Still, they look similar, but they're not yet. So now let's do same, change, flip. Same, change, flip. Okay, now I want to say two things to try to help you come up with an idea of what to do next. The first thing is I'm going to go to that big long list of guidelines, something that I hadn't highlighted yet. Good grief, where is it? There it is. Use a Pythagorean identity. Those are the ones that are squared. Use a Pythagorean identity to multiply by the conjugate. You remember what a conjugate is? We got complex conjugates, we've got radical conjugates. It's kind of like the opposite, sort of. So we could take a binomial, we could multiply by a conjugate in order to create a Pythagorean identity. Okay, so I want you all to ignore the 1. I'm not going to erase it because I did same, change, flip, but just ignore it. Don't let it get in your way of your thinking, okay? Here's where I am. Here's where I want to be. Look at your denominator. Can you, right now, replace 1 minus cosine with sine? Isn't that a thing? 1 minus cosine? Isn't that a thing? No, it's not a thing because they're not squared. This isn't squared. So I can't replace this with a sine. Even though it's where I want to be, I want this to be a sine on the bottom. I want this whole thing to magically turn into sine. It's not going to turn into sine magically, but you can force it to turn into sine if you do this. 1 plus cosine. If you multiply this binomial times this binomial, which is its conjugate, watch what happens. I'll do the numerator first. Distribute my sine into the binomial. So I've got sine of x times 1 plus sine of x times cosine of x over FOIL this out. Why am I telling you to go ahead and FOIL out your denominator? Because that's the whole reason I chose to multiply by this, is so that I could turn it into a sign. So multiply this out. I got first, 1. Outer, positive cosine. Inner, negative cosine. Gone. Last, negative times a positive, cosine squared. We're getting there. We are getting there. This is a thing. Replace it. So I replaced it. Okay. Well, we're close, but I have too many of these now. I want one of these gone. I want to be able to cancel a sign. Careful. If you cancel this sign with this sign, you're going to kill a kitten. Why? Because this sign is connected here with addition. Can't do that. Not only that, when I cancel one of these, what do I want to end up with on the top? 1 plus cosine. So here's the cool thing. See how both of these terms have a sign in them? Pull it out. Pull out a sign from your terms on top. Pull out a sign from this term. What's left? Pull out a sign from this term. What's left? Oh, look. Cancel this one with one of these. Cancel, cancel. Woohoo! We made it. Your hand might hurt from writing so much, but we made it.